Hi, I'm Garrett with IDC Woodcraft, and I'm so glad you've come to this video. If you are one that loves the amazing world of CNC routers and you've gotten your feet a little bit wet, still a beginner, but you want to start getting into some of the 3D stuff like this and this rooster, cock-a-doodle-doo. That's what I'm going to walk you through today. We're going to go step by step through a 3D model project using one of the techniques, and the easiest technique, so you can start making a 3D project by the end of this video. So it's a little lengthy, but it's taking you through every step so that you will know exactly what to do. So you're going to be making stuff by the end of the day that you've never made before. So let's just dive on in and get working on this chicken here. Let's go.
We are in the Vectric software, and I remind you this works the same for Aspire, for Pro, and the desktop variants. You may have a few more buttons on yours, but the steps are all going to be the same. So this is for the beginner. It's a complete walkthrough, and just so you know, this video is by virtue of a one-on-one session I had with Pat, who was working with this 3D type of thing. And if you are struggling with your CNC and just looking like a deer in the headlights, we can do some one-on-one time. There will be a link down below where we can set up some time, and I'll spend an hour in a Zoom call with you. Pat, if you want to share your experience, if you watch this video, please put a comment down below and tell them what you felt. Okay, so we are in the Vectric, and we're going to set up our job. We're going to do single-sided, and the job size, basically the size of your board. So I am set up with a 10 inches wide by 4.5 inches tall and a 1/2 inch deep. We're going to be going off the top surface, and we are going to be working on center. Now, one of the things you want to do when you're doing the 3D stuff is you want to change your modeling resolution, which is right down at the bottom, from standard to high. And the reason you want to do that is for the actual graphics that are going to be generated. And we're going to click OK. So the first thing we want to do is get a model. We want to get a 3D model. Now, I'm using the term 3D. This stuff that we're doing is effectively what they call 2.5D, where it's profiled or on a surface, or in other words, it's a kind of a relief. 3D is, in an all-axis around all orientations. So I'm going to be using the term 3D just because it's easier to say. Being lazy, if you will. All right, so the one to the left and down at the bottom, you're going to see some tabs. There's going to be drawing, modeling, clip art, and layers. First thing we want to do is go to the clip art tab. And when you click that, you're going to have a couple things pop up. But at the very top, there's going to be two tabs. One is the library browser, and the other one is local files. So the library browser is where you're going to import the designs and where they're going to be stored on your computer. So basically, it's a directory within the Vectric directory itself. The other one, the local files, is if you have put things on your computer at certain locations, then you'd use this. But we're going to use the library browser. And there's going to be a couple things up here. We got clip art and design and make. We're going to select clip art. When you click that, it opens up a tree, and you can see down at the bottom, now we've got some stuff that has popped up. Now this is everything that is in our library right now in the clip art library. And then it's also been broken down into a tree just to segment things out. Because you can see down here we have fruit, it's apple, and then we've got some white things, which I'm not going to explain right now. And then what else do we have? Just crossbones, a beer. We're going to go to the animals section. And that's where everything is distinguished. Now, Pat worked on this horse right here, but we are going to do a chicken instead, just because I want to do something different, and I'm going to be making a sign for my sister and brother, sister-in-law brother, who have a farm. Before you can download, if the image that you want has that little black arrow down in the lower right corner, that means you have to download the clip art. And the place that you're going to download that from is from the Vectric website. So when you click that, you may get a dialog box that says you have to be logged in. On that dialog box will be a button that you can go to your Vectric login page, log in, and then it'll download the items that you want. So as you can see, I've already got this chicken right here, is already downloaded. So I'm just going to drag it out and drop it onto the screen. And there is the chicken. Now, of course, the first thing is it's too big for the job. So we're going to work on that. So this is all we need right now. Just one project, one 3D model. And we're going to go over to the drawing tab in the lower left corner of the screen. Just going to click that tab. And we're going to position our rooster. So we're back in the drawing area on the left. And you see under Transform Objects, the very last icon, it says Align Selected Objects. We're going to pick that. And you're going to see a whole bunch of buttons that align your projects in certain different ways. Now we're just going to fiddle with the very top one. What these will do is align your project based on the material. And it'll align it to the center based on the orientation that they're showing. So the first one is side to side. It'll be located on center. When I click that, the rooster will move to the middle of the material. And likewise, the last one will move it up and down, and the middle button will center both at the same time. So we are there, and we are going to close this. And now the rooster has to be brought down to size. So of course you have to click it, and you're going to get the buttons around the rooster. So we're going to select one of these buttons, and I'm going to select the inner button. If you select the outer button, what that does is you'll see a little circle pops up. And if I click my left mouse key and hold it and drag it, you'll see my rooster starts to rotate. So I don't want to do that. And in order to undo whatever you do, just press Control Z and it'll go back to the previous command. So we're going to grab the inner button and we're going to hold our Shift button down and then our left mouse button, and we're going to shrink it down. Now the Shift button allows it to shrink down on center. So if I'm not holding the Shift button down and I click that button, you'll see it's shrinking down from the opposite side, and that's not what I want. So I'm going to Control Z, click it again. I'm going to hover over that button. I'm going to hold the Shift button down and bring it down to the size that I want. So that's pretty good. We have our basic model here. Now, one of the things I want you to do now is to do a split screen. Up in the upper right hand corner, you've got two ways you can split your screen: up and down or side to side. Now, it's usually, for me, it's easier side to side, so that's what we are going to go with. And now you see we have our material and we've got our chicken in there. It's a rooster. I keep calling it a chicken. Well, I hope you'll forgive me. We have to get this prepared for our 3D carving, and we are going to learn one way of doing it today, and what that's going to be is what they call the vector boundary method. So before we dive into that, I just want to show you something here. You see that we have our material here. It's kind of grayed out, and we have the rooster, which is a peach color. Now I'm going to grab this and rotate it a little bit, just like that. And one of the things you can do while you're on either screen is you can grab that rooster and move it around just like that. So you can reposition it while you're over your 3D model. I'm going to Control Z to bring it back. We're going to click the rooster. Now you can click the rooster in either one. So one of the things we want to make sure of is the rooster is completely within the material, meaning it's not above the top surface. You will know by the color change of parts of the rooster. Now I'm going to show you what I mean. You'll see there's a little blue button down at the bottom of the rooster when it's selected. When I click that, a little menu comes up. Now there's lots of stuff on this menu, and I'm not going to get into it. This is I just want to get you to a point where you can actually cut but I want you to see what it looks like if your project is sticking out and how to fix it. So when you click the blue button, this menu comes up and you'll see the base height slider right here and a field where you can put a number in. So if you grab that slider and slide it up, watch what happens with the rooster. Now you see some pink or more orange has shown up. Those are the areas where the features of the rooster are above the top surface of your material. And we don't want that. So we are going to slide that back down. But I want to show you if we go too far, let's just exaggerate this a little bit. Okay, so now you see that the rooster, don't want to do that. Okay. Let me orient this the right way. So we are on the plane. I guess I can just push that button there. And now you can see that the rooster is actually below the plane. And what we want to do is bring that back to the plane. So just type in 0. And it has moved back to the plane. I'm going to close that and I'm going to reposition to Z. So what I did was I used the orientation buttons up here on the upper right corner within the window that's showing the 3D. So our rooster is within the boundaries of the material, so we are good to go. So what we're going to do now is come over to our left bottom and we're going to go back to the tabs and we're going to select the modeling tab right down here. When you select that, now you see we have a layer and we have our rooster. And the rooster is highlighted. What we want to do is just click the rooster once. And by the way, if the rooster is not selected at all, then it's just going to be grayed out as it is there. If you click it once, it's darkened up, it is selected. You don't have to click it twice to get the buttons around there. So we're just going to highlight it like that. Now I want you to see the features in the upper left corner. I'm going to just briefly explain some of them and then we're going to get into one or two of them. So the first one is import a component or 3D model. That's if you have purchased something from somewhere, a 3D model, you would use that feature to import it into your drawing. The next one is change the properties of the selected components. When I click that button, you're going to notice something. This has all the same features as that little pop-up did when we had the blue buttons selected over in the 3D window area over here. So we're not going to mess with that right now because I just want to get you to a point where you're carving something pretty cool. Then we have this create a vector boundary around the selected components. Now this is the method we're going to use, so we'll get back to that. And we have apply a smoothing filter, which we're not going to use at the moment. Next one is scale the Z height of the model. This is where you can tell if your model is above or below the surface or the bottom of the material. And when we open that up, as long as we're seeing maximum Z is a negative number or 0, but does not go positive, we are in good shape. And it is 0.2159 minus, that means it's not going through our material. Our material is 1/2 inch thick. We're going to cancel that. And the next one is slice visible model into individual component slices. So that's when you have a 3D model that is thicker than what your machine can handle. Then you'll segment it out. So let's just say you're trying to carve a full-size bust of a head. Then obviously for most CNC routers you can't get that. So this will allow you to segment it out so you can glue all the pieces together. And finally we have add a plane component with 0 height converting model. So we are not going to fiddle with that. I'm not even going to dive into that explanation. What we want to do is come back to create a vector boundary. So if I click that right now, let's zoom into our rooster. Down in the tree, nothing is selected. And you know it's selected when it's blue like that. and you see the rooster change color. So we have to have something selected. And we select this create vector boundary. And I want you to watch what happens when I click it on the boundary of the rooster here. So what it did, it actually created a circle around the maximum diameter. What this is doing, it's telling Vectric that all the 3D work that it's going to be doing will be contained within this boundary. So that is all we really need to do. It's now time to set up our toolpaths. So up at the top, upper right, you've got the little blue arrow button that says go look on the other side of the page. When you click that, the toolpath area shows up. And we are now going to explore the 3D modeling toolpaths and generate some G-code for this. Before we get into the 3D tooling aspect, if you're finding this useful, take a minute out and give me a thumbs up and maybe a comment if you would. Also, if you are new to this stuff and you're just struggling through it and you're really having a hard time in either the design area, not just Vectric, but Carbide Create, easel, Fusion 360, any of those, or your CNC router, just any aspect about it, I'll be more than happy to do one-on-one with you. You can schedule a time. There's a link down below in the description to set that up. And you know as well as I do, when you have that one-on-one, you accelerate much faster. So if you're getting frustrated, just set something up and we'll get you worked through it so you can get to the next step a lot faster. Okay, let's dive back in and set up our toolpath. Let's go. In the toolpaths, you're going to see two buttons. One looks like a round stacked or step pyramid type of feature, and the other one is a half of a ball, for lack of a better explanation. And we are going to click that first one, the step pyramid. This is our roughing cut, where we're hogging out some material that's just to get it out of the way. The other one is going to give all our finished details and make a very nice project. So we click the rough machining toolpath. So the first thing you want to do is hog out some material. And so we want to select our tool or our CNC router bit. So you select it. Typically you want to go with a 1/4 inch end mill. And that is what we have selected. And then I'm going to go into the edit button. And what that will allow me to do is change the router bit setting for this job only. So I open that up and there's several things. I've got my step over. That's one of the important things that you need to pay attention to, and the feed rates and the plunge rates. My step over is at 40%, which means it is going to make a cut, and then it's going to move over 40% the diameter of the router bit, and then start making another cut. What I'm going to do is change just to 50%. And I want my feed rate to be 40 inches per minute. My plunge is 10 inches per minute, so that's good. And we're going to go with that. Now, in the next one, it says machining limit boundaries. So there's several different features here in order to get you to making a 3D part. We're not going to go into deep explanation of these things. I'm just going to brief over it. You have the model boundary. That is the boundary of the model itself, which we could work with. We have the material boundary, which is the actual job size right here, the whole board. And we have selected vector, and then we have selected level. So I'm not going to go into that feature. That's getting a little more advanced. What we want to do is go to selected vector or vectors. What we're telling Vectric to do is only work within the vector that we've created. So you remember over here we created that circle. So we're going to select that circle. And now that is almost ready to go. You're going to see boundary offset. When you use a number in an offset feature like this, it essentially tells the software that we are changing the diameter of our cutting tool. So I'm going to do another video on that at some point so you understand this type of offset factor or number. And then we go into our machining allowance. So this is something just to be aware of what it does. I am going to reorient this rooster here to look at the plane and just kind of drag it down just a little bit so we can, there we go. All right, so this is the top of the job. This machining allowance says that in wherever the roughing bit goes, it will never go closer to the finished surface than the number that's in here. Meaning we have a 0.04 currently in this field. That means that the router bit itself, the closest it will ever get to the finished surface of the 3D carve is 0.04 of an inch. So it's leaving that depth of material at some given point. And that gives us the finished material that we can carve off in our finish operation. So when we're looking at the top of the material, the router bit will never come closer to a finished. Let's just pretend this is a 3D surface. So it's got contour to it. The router bit will never come closer than a 0.04. So I hope that made sense. All right, the next one is the roughing strategy. So there are two different ways that we can do this. So what the roughing strategy is basically how are we going to cut this material out? The first one is Z level, and essentially that's like an offset type of cutting pattern. If you've done any cutting, you'll know that the offset will find the location of some point and start to work its way out in a kind of a going around the perimeter fashion until it gets most of the material cut out. The 3D raster actually follows the contour of the project. So we're going to demonstrate this. So I'm going to just stay with Z level, and before we get back to that, I want to point this out to you. We have a ramp plunge move. If you are using a down bit, whenever you're using a down bit, you want to use a ramp plunge move. A plunge is when the router bit goes down into the material. With a down cutting end mill, the flutes on the end mill are rotating negative relative to the rotation. If you've done some work, you know that it leaves a very good edge. However, there's a lot of pressure being applied at the bottom because it doesn't have a bottom cutting edge. So it has to work its way in. So if you try to do a straight plunge with a down bit, then you can potentially run into some problems. So you always want to do a ramp in any of your jobs, and you want that ramp to be at least half the diameter of the tool. So we're going to do a 0.125 since we're using a 1/4 inch router bit. Okay, so that was just an important note I want you to understand. Just always, by default, use a ramp plunge move. Just do it. Okay, so we are in a Z level roughing strategy. So I'm going to click calculate, and what we're going to see is some lines here on our project, and I'm going to just preview that toolpath. And this is basically what that 1/4 inch end mill is going to cut out. So essentially just took out material it didn't need. This is to get stuff out of the way. Now I'm going to go back in to this toolpath by double clicking it, and I'm going to change it to the 3D raster. And I'm going to calculate, and you can see right away that the toolpath looks very different. And if I preview it, now we've got something that looks kind of like a chicken forming. So let's take a look at something. I'm going to close that and go to the clock right here to see how long that particular toolpath took. And it says it's going to take about 5 minutes and 30 seconds. So I'm going to close that. We're going to go back into this, and we're going to select the Z level offset. And we're going to calculate, reset, and show the toolpath. And then I'm going to go back to the clock. And this is 2 minutes and 12 seconds. So half the time. Now that kind of time, the short period of 2 to 5 minutes, that's kind of nominal, but it can be an issue if you do much bigger projects. So we're going to stay with this particular toolpath operation, and I'm going to close the clock. And we're going to go, we have our roughing done now. We are now going to go into our finish toolpath. We're going to click that. And our screen looks generally the same for job setup, but there are some differences here. Now the first one is, which router bit are you going to use?
Now, one of the router bits that's commonly used in carving is the carving bit, this long, mean looking guy right there. The other bit we're going to be talking about is the 1/8" ball end mill. Let me just zoom in a bit. And you see the flutes on it are rounded. And there's a big difference between the two, and it's the diameter. So we'll get into that a little bit, but I just want you to understand the difference between the two that we're going to be talking about now.
So I want to tell you, you don't necessarily have to have the carving bit. You can do a very nice job with a 1/8" ball nose end mill or a 1/16 ball nose end mill. So what I'm going to do is I'm going to select the 1/8" ball nose, and we'll show you the difference. So we're going to select that, and we're going to just click OK. And then you remember we have the machining limit boundary. We again have the selected vector or vectors, and it is selected over here on the left. And we are in the area machining strategy, and it is selected at offset. The step over retract, we can leave that alone. I'm not going to explain that right now because we just want you to make a project. You want to stay in the climb mode, and then we're going to click calculate. So now this is going to generate our finished toolpath, and the toolpath is going to be in a circular fashion, starting from the middle and work its way out. Now we're going to run this. We're going to preview it, and we've got a nice little rooster here. So what the Vectric did was it programmed it starting from the middle and working its way out, and it's going to do a step over every time. You remember, a step over is a percentage of the tool of the router bit, and a step over on this router bit, let's go back in and take a look. You want to go up to edit, and our step over is at 7%. So that's really what you want to work with, 5 to 7% for your finish work. You want your step over to be a small percentage of the tool, especially since we're using a ball nose. And we are at 40 inches per minute, which is, that's a little aggressive for an 1/8" diameter bit. However, because we are only taking 7% of the diameter of the router bit, that's okay. And that speed is actually going to make a big difference. You may even want to go higher. We can go up to 45. It's doing, matter of fact, I'll do that, 45. And we're selecting OK. Now, we have our offset strategy and our raster strategy. Now you saw the offset was going around. I'm going to cancel this because I'm going to recalculate it, because I want you to see the differences in time. Okay, so we're going to close that. It's calculated, and we hit the clock again. And I'm just going to select them both. So you can see that the 3D finish is 32 minutes and 46 seconds with that router bit and the settings. So remember that, 32 minutes. We're going to close that. We're going to go back into the finished toolpath, and we are going to use the raster toolpath. Now, before I do that, I want you to just look at the blue pattern over here. You can see it's circular as best as you can. The bit started out in the center and worked its way out. Now when we calculate on a raster, it's going to go side to side. So the router bit will start at the bottom, or the defined location that you set, and that's going to go back and forth, working its way to cut out this, or to carve it. Now watch the toolpath when I run it. I'm going to have to refresh that so you can see it. So you can see it's going back and forth. And the image looks pretty much the same. Now you see we got a little bit of cusping going on right in here. Generally, in projects like this, that's not going to be noticed by the person who gets this project or you. You're going to see the rooster. You're not going to see the little details in the rooster. However, I want you to see what happens when we get really fine. So I'm going to open up my snipping tool and take a quick picture of that so you can see that and see what the differences are. What we're going to do now is use that carving bit, the long, mean looking bit. We are going to go back into the finishing toolpath. And I'm going to select back to offset over here. And then we're going to select our tool. And the tool we are now going to select is the 5-degree ball nose tapered end mill. This has a very small radius on the end, a millimeter radius. And let's take a look at our step over, which is 8%. We're at a 40 inches feed rate. Let's go 45 since I changed the other one to 45. Because I want to give you a comparison of what the difference is, not only in how the picture looks, the finished project, but the time that's going to take. So we are now going to calculate. And the computer is going to take a little bit longer on this, because it has a lot more calculation to do. Before I even show you the image, I want you to look at the time that it's going to take. So we're going back to the clock, and you can see now it's 1 hour 31 minutes. So we are virtually an hour longer in run time. And if we run this toolpath, our rooster is much more crisp. Let's open up this image. You can see the feathers are much more detailed. The wings, let's take a look at the face of the rooster. It's definitely cleaner. There's no cusping down on the bottom here. Now you see there's a little bit of radial marks here. You don't really see that in the project when it's running. So it's up to you if you want to make the trade-off. If you want a really highly detailed project, then you are going to use the finer bit. In my eyes, when I give a gift like this to somebody, which is going to be a sign, a farm, like I said, they're not going to see that. They're going to see the whole sign and see the rooster carved out as it is in this image, and they're going to be very happy with the project. So just keep in mind, what is your buyer, if you were selling the sign, what are they really going to see? They're going to see the entire project. So now what we're going to do is save these tool paths. So I'm going to put my USB drive in, and I'm going to get this alarm, which is driving me crazy. And we're going to close this, and now we're going to go to the save area, and we're going to click that. And what we're going to select is we're going to select the visible toolpaths to multiple files. And down below, we're going to select the toolpaths. And what it's going to do is going to create all the files at one time. And when we say visible toolpaths, when you select the toolpaths down here in the lower right, and they're checked, that means they're visible. And then we're going to go to the Save Toolpaths. Now, I want you to understand a little something here. Some people ask me, how does the machine know when to change the router bit? Well, that's going to be determined by your post processor. The post processor right here is a file that tells Vectric the settings of your CNC router. If your CNC router has what's called a tool changer on it, where it can have multiple tools already there and the machine will change the tools at itself, then your post processor will set that up in Vectric, and Vectric will know that, and it'll write the files accordingly. So you can have one G-code file to run the whole thing and the machine will change itself. However, I am using a Bob CNC. It does not have that feature, so it will not allow me to write files with different types of tools. It'll separate the files into separate G-code files. So I'm going to show that to you. So we have both of these selected, and we're going to save the toolpaths. So I'm going to click that, and I'm going to scroll to the USB drive. And you can see it is naming this 3D Roughing 1. Now, if you look down here in the lower right, there are the two toolpaths. One is 3D Roughing 1, and the other one is 3D Finish 1. But it only has one name here. What I'm going to do is just click Save. And then I'm going to open up that directory. It says right here, and I'm going to refresh it. And here's what we have now. We have two G-code files. We have 3D Roughing 1, and the other one says 3D Roughing 1. So that's the first part of the name. And then in the second part of the name, it says 3D Roughing 1 and then 3D Finish 1. So now you understand we have two different G-code files that it created. So essentially, you can't run both bits at one time. You're going to have to load up a separate program. Okay, so there we have that, and we are now going to take it over to the CNC router, and we are going to run this out.
I'm going to be cutting this job into this piece of walnut. So that's 5 inches wide, and I actually said it was 4.5 in my software. So our rooster is actually going to be 4 inches in diameter. Not very big, but you're going to see the detail you get out of it. The two router bits we're going to be using is the 1/4 inch down bit to do the rough out, just like we set up in the program, and then we are going to use the ball nose end mill. Now, if you're brand new to CNC and you don't have any of these bits, I just want to point out to you that I do sell CNC router bits as a set, and I'm working on selling them individually. So in case you're interested, there's going to be a link down below, and what you get in that set are 3 V-bits, that's 30, 60, and 90. You're going to get 3 flat bottom end mills, a 1/16, an 1/8, and a 1/4, down bits there and up bit there, and then a 1/4 inch ball nose and an 1/8 inch ball nose. Plus you're going to get a whole bunch of files. You may want to take a look at that. Again, the link is down below. So we're going to be using the ball nose and the 1/4 inch down bit. And of course, remember, if you're finding this helpful, thumbs up. If you want some one-on-one, there's a link down below to set that up as well. So what I'm going to show you now is getting the program into the computer, setting up our 0, and starting the router and running through the entire project. I know this is a long video, but it's all step by step, so that you know exactly what to do. All right, let's get this program into the computer. I'm using Universal G-Code Center, and I have just inserted my flash drive into the computer. So I'm just going to load it up by clicking the file open. And then I have to pick the file. So the first one is going to be the roughing program that says Roughing 1 behind it. Remember, we have the roughing and the finishing. So we're going to select that one first, and you'll know on the image if you've got the right program. That is basically ready to go. Now we have to zero out our start position on the machine. Now you can see on the image here that the start position is right in the middle of the job. So I'm going to have to center the tool, the 0 point, up in the center of the job. And the way I'm going to do that is by starting with a pen mark. So I'm going to just pick half the point. So we've got 4 and about 4 3/4, so it's going to be 2 and a little less than 2.5. So I make a dot there, and I know it's pretty much on center there. Yeah, we'll move it over just a little bit. So I'm going to put it right there where I got that little X. So we are now ready to go. And I just want to show you something. If you have a Bob's CNC, either an E3 or E4, I want you to see my dust on the rail solution with the help of my friend David. Beautiful, perfect guards that keep the dust off the rails. If you're interested in that, then I'm going to be putting it on the market. Make a comment down below if this is something that you want to know more about. All right, let's run this job out.
So we are starting off with the 1/4 inch down bit, and it is doing a raster type of cut, back and forth. That's the way Vectric sets it up, because it's just roughing stuff out. It's the most efficient. And I want you to take notice, every time it goes down, it does a little back and forth move. That's the ramping in. So it's just going around. We're going to speed this up a little bit as it cleans things up. Not much material that is being removed. And now it's doing what's called an offset profile cut. It's just cleaning up the outside. So now I want you to just take a look at the rooster. I ran the other type of Toolpath and I forgot to film it, so my apologies. It ran about twice as long as that one did. And now we're going to use the 1/8 inch ball nose end mill. And you're going to see it's going to do just fine. So we've got the flash drive loaded in the computer, and we are going to open the flash drive up. And we've got the two programs, the roughing program and the finishing program. So we're going to select the finishing program. And it's going to take a second to load up, but here it is. And it's all blue because there's so many tool paths. And all we have to do is hit start once the tool is set up, the router bit. And here we go. So it is doing that offset type of cut where it's started in the middle and it's working its way out. It's stepping over by 7% each time. Now the router bit and the router are moving up and down as it's making this move. You can't always see it, but you can watch your collet go back and forth. And that's how we know that this thing's running. It has 140,000 lines of G code to do all of this. It's a very long program. However, it's a small part. Just imagine when you have something twice as big. You can see again, it's riding up and down as it moves along. And what's really cool about this stuff is the surface is almost, you don't need to sand it. It's very smooth. So let's speed it back up and watch how this forms out. Very cool. Rooster showed up. Now I'm not running this out to the complete bowl shape because this was done for this video. So now we're going to do a comparison. We are going to use the carving bit, and because it's going to run at least 3 times as long, we're not going to run the whole thing out, just enough to get the rooster. So we're going to run it in the same type of tool path. This is run at the same feed rate of 45 inches per minute. And its offset is 7% or 8%, I don't remember. But you can see it's taken a bit longer to work its way out. Now just so you know, just to run out this chicken took 1.5 hours. So when you're using this bit and you're working on big jobs, expect it to run for quite a while. But what's interesting is look at the difference in the detail of the rooster. The feathers down by the leg, the tail feathers, and watch how the head forms. I'm going to speed this back up. Again, remember, if you want some one-on-one, don't be afraid to ask. That's what I'm here for. And it's no sense in beating yourself up trying to figure it out when you can get somebody in there helping you and get you going twice as fast. Again, the link is down below for that. So take a look at this, how much crisper the rooster is. The trade-off is the time that the machine is going to run. You see when you get close up, there is some burr in there, and it really depends on the grain of the wood. I got a little bit of lines in there. I'm not sure what's causing that, but it's so fine that you almost can't see it. But I'd sand it out. And look at the detail of the size. It's only that big, 2.5 inches tall. Very crisp details. If this helped you out, like I said, thumbs up. This tutorial is taking you on a deep dive to get you to the next level. So you have it literally step by step. I know it took a long time. I got to hand it to you that you stuck around through the whole thing. Now, I'm going to say it again. If you are struggling through this stuff, the design or your CNC, you just don't understand it, get some help. You don't have to beat yourself up. You will get there 10 times faster. I am here to give you a hand. So look at the comments like what Pat has made about what I've done, or Jeff when it comes to the entrepreneurialism. And by the way, if you want to make some money with your CNC, join the CNC Entrepreneurs Facebook group. You know, this is an amazing craft, right? And you're in it now, right? And you're learning this amazing stuff, and now you can do something like to the next level. So what I want from you, aside from the thumbs up and a comment, is I would love to see a picture of your first 3D project. So email it to me. My contact information is on my website, idcwoodcraft.com. Hey, this is Garrett. I'm glad I've gotten you to the next level, and I will talk to you next time.